So last meeting, I've shown you the solutions, no, to the analytical engine exercises, and then I've shown you also a sample program that will do an if then else, no, because most programming languages will have if then else, no, right? What may I ask again? What programming languages you are using? Programming language you are using in your other class?
Python, sir.
Oh, Python. Okay.
Python.
I will show you briefly, no, a sample code in Python and C++ because some of you are having C++. How do you do your Python? You download a Python, of course, no, and you download an Python editor. What's the popular editor? PyCharms, di ba? Popular Python editor. But if you don't have an editor, you can go to programmers.com. No, it has a C++ and a Python editor. No, have you used this before in your Python? What are you using? Anyone? Okay. Let's show this in no. Idle pala is another editor, no, in Python. Okay. We will create a program, no, just to show you the branching. Are you in branching already? GORM versus VS Code. Okay. So pwede na, you can download Python and then a Python editor. VS Code is also valid. But if you don't have, you can go here. No? So for example, we can type this. You know this, right? Sorry. Diba? Do you know if then else, no? In Python? Can you see my my screen, everyone? So
Yes, sir.
you know what this means, right? It inputs 3 variables, all of them integers, no? First, we enter the score, then the items and the base of conversion, because in our last program, we use the base conversion program, which will compute the grade. Ito, no? Which will compute the grade and determine whether the passing or not, no? The problem is we don't have an if then else statement. You know what branching is? Are you in branching already in Python? Okay. So branching is a structure or a facility in a language that will allow you to make, or your program to make decisions. Can you mute first? No? Paki-mute lang. And then you just raise your hand if you have some point, or chat me if you have some point. No? So ito, for example, we run it here. No? Pwede mo rin i-clear and then run it again from the beginning. Okay? Do you follow? So input is a command in Python to ask for a value. All inputs will return strings. So we use the int converter to convert these variables. S is our score, I is our items, and B is our base. Okay, do you follow? Okay, and then we will now have another variable, which is grade, no? G. So you're doing Python, so anybody can tell me what this is? If you're doing Python, this computes the grade, no? By dividing score with items times quantity 100 minus B plus B. Okay? Do you follow? And then we will print the grade like this. Okay? So for example, if we run enter a score of 30, items of 100, base of 40, computes the grade 58. Okay, and then you can make a decision in Python, no? what you do to make a decision is use an if then else statement. If G is greater than 74.99, we print you pass the test. Now, conditions are terminated with colons. Ito, no? Else are also terminated with colons. We print try again next time. Let's clear this and run it again. So, for example, you have 60, a score of 60 over 100 items. And then you have a base of conversion, which is 40. Your grade is 76, you pass the test. No? This is the branch which was executed. Then we run 100, shall we say 30, 20, no? I-clear muna natin. 30, 100, okay, base conversion which is 40. Okay, so try again next time. That is because it's failing. Do you follow? Okay, so this is the importance of branching. Briefly, let me show you the equivalent in C++ because some students are doing C++, right? Same site, different, ano, okay? Do you follow? Ito yung equivalent sa C++. Let me just copy and paste. I was wondering, no, why are you using different languages? No, ito, no. So we have float SIB, score items and base. We have float G, which is grade. Okay, and then we C out is used to put an output. C in is used to get an input. Okay, C out again to enter the item. C in to get the items, not to I. This is how you do it in C++, no? Also in C# using IO stream. Okay, we run this. I don't have to place it anymore, no? 60, 100, 40. So there's branching, no? So if you run it again, you'll say 30. The items is 100. The base is 40. Okay. So that's where it is. Okay. So more or less, I'm trying to give you an idea of what is the importance of branching. No? And then we had a worksheet which is here. Grade computation. No? Here. So what we did is, in order to check if the score or rather the grade is greater than or equal to 74.99, we did a minus. We follow with our score, rather grade, which is computed as 76, with a cutoff of 74.99. Do you follow? So when we minus and it's negative, okay, we will see F4, which means that we will compute the result as 1 by multiplying L005 with itself, which is 1, which is 1 times 1 becomes 1. Okay, and we store it to the result. So it's like saying, congratulations, you passed the test. No? If you failed, we have set initially the result to be 0. So if you fail, it will not skip. It will just go to a print, bell, and halt. So therefore, it's just like saying, better luck next time. Okay? Do you follow? No? So the point here is, even according to Alan Turing, the analytical engine is a complete machine. It's a Turing complete machine, which means like a modern computer, it can do computations, it can do repetitions, and it can do branching. No? So in our case, we have demonstrated repetition by using CB. Okay. Now we have demonstrated using, rather branching using CF. Do you follow? Because some students were asking me before, what's the use of CF? We know that CB is used for looping. CF is used for branching. Okay? Any questions so far? Have a great Okay, now let's proceed to a new lesson. We will now introduce a new computer. No, can you look at your Dagler 20. Tapos na tayo dito, no? Sa Enigma machines, the ENIAC. Now, during the war, no, before the pre-electronic period, the most popular computer that came about in the US was ENIAC. Okay, in fact, the inventors of ENIAC, okay, tried to secure a patent for ENIAC being the first electronic computer, no? Although it's not binary, we know that, no? However, it was recalled later, no? The official electronic binary computer considered to be the first in the US is what? The ABC computer. Okay, the ABC computer by Atanasov and Berry. And then the next computer considered to be competing for the stored program concept is both EDVAC and the IAS. No? EDVAC is an upgrade of ENIAC. Okay, pareho lang sila. But the main difference now is the stored program concept. But the stored program concept was considered to be first implemented into the IAS. What is IAS? IAS is an Institute of Advanced Sciences. It's a research department in the Princeton University. Do you follow? It's the counterpart of Moore School of Engineering at Penn State. Magkalaban sila. Do you follow? Universities competing with each other. Okay? EDVAC was supposed to be the first to be produced. But later, no, IAS overtook it, no, during the actual production. They were both released in 1951. However, the stored program concept was accredited to John von Neumann, not to Eckert and Moseley. Why is that? Because before EDVAC was released, no, in the 1940s, I think 1948, John von Neumann published a report on the stored program concept in EDVAC. Do you follow? I-publish niya yun. If you are publishing a report like that, you will be sued for plagiarism because it's not your work. However, Eckert and Moseley did not contest that. No, so people assume which means that the original author of the design of EDVAC is John von Neumann. Do you follow? And there's a controversy that followed. No? A court case was filed against Eckert and Moseley, withdrawing the patent for ENIAC, and it was really withdrawn. I will tell you the story later. Okay, the story about that. The most important thing is the IAS. We will not study the EDVAC anymore, no. But however, we can show that, no, the structure of the EDVAC later. Okay. Before we introduce, no, the IAS, let's study its evolution. Okay, as usual. Okay. Any questions so far? The stored program concept was started during 1945 by John von Neumann in the Institute of Advanced Sciences in Princeton University in the US. Princeton is a very popular university. Okay. Stored program concept. What is this all about? No, bago ito during that time. No, it's a new technology. It's a new architecture called the Nuemann architecture. It's also called the Princeton architecture, no? Because it comes from Princeton. Stores program and data and instruction. Stores the program, both data and instruction, in the same memory. Okay? A computer which uses separate memories as the same as the analytical engine is considered to be Harvard architecture. It's now dead, no? Harvard because of Harvard Mark I, okay, by Sinong author niyan? Howard Aiken, no? During those times, no, there are three universities competing, no? Harvard, Princeton, and Penn State. And of course, fourth pala, meron pala yung Iowa State, no? Okay. So, the IAS machine was a binary computer with 40-bit word. This is strange, no? Very strange. Syllabor. Waiting. Nandiyan pa ba? Anyway, na-check ko na. Next time, I've reconfigured this to do away with the waiting room, but it's still there. No? I-check ko nga, no? Hassle yung waiting room. I'll try to check that right after, no? Okay, so we are recorded. So it's a 40-bit word. It follows the analytical engine convention of using 40-bit words. But this time the instructions, unlike in the analytical engine, 40-bit word regardless whether it's instruction or data. No? Do you follow? Right? Now, for the IAS, it varies. It's 40-bit word for storing data and 20-bit instructions for instructions. Do you follow? So strange ito, which means that there are two instructions which can be formed or fit in a word. Do you follow? So this was later abolished, no, because this made the IAS difficult to program. Okay? So with 40-bit words, it has a memory of 1024 words. Okay? Do you follow? Or 5.1 kilobytes. That's because 1024 times 40 divided by 8. But the byte was not yet popular at that time. No? Do you follow? By now, we'll say it's about 5.1 kilobytes. Okay? And the IAS is able to represent negative numbers in 2's complement form. We'll study 2's complement in the future. No? And then it uses floating point representation. Okay? We will also in the future differentiate floating point from fixed point. Okay? Any questions so far? Here's a comparison, no, between the analytical engine and the IAS computer. Can you see this? Everyone?
Yes, sir.
Okay. Okay. So an important factor in a computer architecture is the number system. Okay. The analytical engine uses fixed point 40 digits. Now, the IAS is much more powerful. It uses 40 bits of floating point binary. There's a big difference. Mas accurate yung mga floating point. Okay. For the processing unit, the analytical engine has 2 input registers and 1 output register. No. Now, for the IAS, the processing unit is divided into 2 main parts. We'll find that out. No. The mill was split into 2. An ALU, or an arithmetic logic unit, okay, which has an accumulator register similar to ENIAC. Do you follow? Being an accumulator, it can be used both for input and output. No? Do you follow? So there are now 2 parts of the mill, no? The ALU, or the arithmetic logic unit, and the control unit. We will look at the structure later. No? For the input and output, no, the analytical engine uses Jacquard Bloom. Okay? The IAS uses an input and output device. No? It's not said, but most probably it's film-based. No? Pwede siyang tape or punch cards. However, there's no keyboard and mouse and monitor. Okay? Now let's look at the IAS computer. So ito yung IAS. Oh. Let's look at it with the author. Ito yung author, si John van Neumann. Okay? Okay? And one of his colleagues, no? Si ano, basta is also important. So, there's no keyboard. It has a memory. Itong mga ano, these are tapes, or I'm not sure if it's wires, no? But it looks like tapes for me. Okay? Do you follow? So, ang input out, now the main difference is here, no? Kasi in this stored program, the analytical engine is not stored program. We'll have to emphasize this. Labor is here already, right? Okay. Okay. In the analytical engine, programs are loaded sequentially from the Jacquard loom. Diba? I-arrange sila. There's an analyst and there's an attendant. The analyst gives the set of cards and the attendant arranges them in the Jacquard loom for processing sequentially, one by one, first to last. Okay, and the data is stored separately in the store. So how can you describe the program execution? The programs are fetched from the cards one by one and run and executed into the mill. Okay, what's the problem with this? Anyone? Anyone can describe to me the problem?
Yes.
Yes. What's the problem with this? It's like, you know, if in a modern computer, running the program from the hard disk directly. It's from the device, no? From the input device. Running the program from the hard disk. The problem here is there's a big difference between the speed of the hard disk and the speed of the memory. Diba? So if you're going to run the program from the hard disk, even using modern computers, it will be very slow. Okay? So that is the important discovery of John van Neumann. Okay? John van Neumann is an important figure in computer evolution. Okay? Almost the same level as Charles Babbage and Alan Turing. Okay? So, what did John van Neumann do? Okay? So, according to his design, instead of loading the programs from input one by one, we load them as a whole by batch. Okay? That's what happens nowadays. Your exe file is loaded into the memory fully. Okay? From storage to memory, from your hard disk to memory. Now, instructions and data, which are both stored in memory, are run from there. Do you follow? So the fetch and execute will come from memory, not from the hard disk. Instructions are fetched sequentially from memory to CPU during program execution. So program execution has two cycles. Fetch the instruction from memory into the CPU and execute it there. So fetch and execution. This is called the stored program concept. Okay? Do you follow? Do you see the significance of the invention of John van Neumann? Any questions? Okay? So yun yung stored program concept. Okay? Which means that programs and data are stored in the same memory before they are executed. Let's look at the diagram of the IAS. No? This is the IAS, different from the mill. No? We now have two main components in the CPU. Okay, we have the ALU and we have the control unit. Okay, in the ALU we have the accumulator register, which stores everything. No, it's used for both for input and output. MQ is where you store the quotient or the multiplier. The quotient during division, multiplier during multiplication, or addend during addition. Okay, or subtrahend during subtraction. No, the MBR is like a buffer register which stores the data which comes from memory before they are transferred to AC and MQ. Okay. Now the control unit has an IBR, no, or an instruction buffer register, because when an instruction is loaded into memory, it is later split into two. Okay, it goes into the IBR and split into two. The instruction goes into the instruction register, and the operand address goes into the memory address register. We'll have more explanations on this, no? MAR, PC, no? Program counter. The program counter is the counter of the number of commands that have been executed. It's also actually an address of the next instruction in memory to be fetched. Okay, do you follow? Now, can we have a diagram of the EDVAC? So the first draft report on EDVAC was written by John van Neumann. Wala siyang nilagay, no? But anyway, let's get the link. Okay, dagdag ko na lang ito, no? Just to mention EDVAC. I'm not including EDVAC usually, no? When was this done? 1945, no? Si John van Neumann, no? Ang author nito. And it's not Eckert and Mockley. Okay, very strange, no? Because during the time, there was already plagiarism. Okay. That's just like you do copy and paste today, no? Okay. What is EDVAC? This is the competitor of IAS. Okay, I'd like you to read that, no? The draft report of John van Neumann regarding EDVAC, which was the invention of Eckert and Mockley. But the real story is John van Neumann was initially part of the team that developed EDVAC. Okay, that's why he was able to publish the report. Without John and Eckert and Mockley being able to contend, okay, to raise contention. Di sila di sila naka-complain. Okay. Dito na lang. Dito. Dito na lang. Remember, no? The EDVAC is like a close copy of the IAS. Halos pareho. Okay? So it's there, no? I'd like you to read that, no? The first draft report on EDVAC, released in 1945. But EDVAC was released, the machine was released for military use in 1951. Okay? Questions? So I'm going to ask you questions later, no? Okay. Kaya hindi ko matapos ito. Sorry. Hanggang anong oras tayo? 6:40 ba? Kasi natapos ko to sa other class eh. Matapos ito. Okay. Now let's look at the IAS machine instruction, okay? So, can you see this? Or do you have to expand? AX natin ito. Can you see this? It's in our regular class. Everyone, can you see this?
Yes,
Okay.
sir.
So, this is the set of instructions that can be run on the IAS. And if you look at that, no, it has close similarities to the analytical engine. Okay. Now, instructions, being a binary computer, are encoded in the IAS, no? So instructions can be coded binary. Okay. So there's a load instruction. There are several load instructions, no? Load MQ loads the MQ register. Okay. In the analytical engine, the first load goes to AX1. IX1 pala, no? Ingress axis 1. The second load goes to ingress axis 2. Here you don't have, no, you have to specify where to load. When you say load MQ, we load it to the MQ register. Okay. Otherwise, it will be loaded to the AC. Okay. When you say load MQ MX, we load MQ with an address in memory specified by X. Okay. Parang L001. Ito, load 001, which means the address of one memory goes to MQ. There's also a store, no? Store MX. X is the address in memory. Okay. Load MX is the default load. When you don't specify which register is the destination of the load, it goes to the accumulator. Okay. Load MX loads memory address X to the accumulator. Negative MX converts it to negative before loading it to the accumulator. Absolute, remove possible values, no? And load dash MX absolute first and then negative to make sure it's negative. Okay. And there are store instructions, no? Now, the problem is there's a store to the store left and store right. Okay. Why? Because during an instruction, no, when you transfer, no, okay, you store the left. Okay, you store the left, the accumulator. The accumulator only has 20 bits. Store the accumulator to the left of X. Okay. To the right of X, no? Kung store 28 to 39, 8 to 19 is left. 28 to 39 is right. Okay. But for a full instruction, left is 0 to 19 and right is 20 to 39. Okay. So we have a fixed jump. Sorry. When you say jump X 0 to 19, jump to the left of this address. Jump X 20 to 39, jump to the right of that address. Okay. Now there's a conditional jump. The strange thing about this jump is it looks like CB. CB ba? Count backward ng ng analytical engine. When will you count backward? If the result is negative. Do you follow? Okay. But in the IAS, it's different. Okay. You only jump if the result is positive. Baliktad yung kanyang why did he invert it? We don't know. Because authors will always have those preferences, no? So jump plus to the right if the result, if the accumulator is positive. If it's negative, it will not. Do you follow? So it's the converse. Now, what's the problem with this? If we try to attempt to convert our analytical engine programs to IAS, we will have a problem with jumps. Why? Anyone? Anyone? What's the problem with the jump in the analytic IAS? It jumps if positive yung result, 0 or plus. The analytical engine jumps if it's negative. Diba? So we cannot just convert programs easily. Okay? Any questions so far? Okay. Now let's look at the sample IAS programs. Okay. Ito yon. Ito na ngayon. Fourth factorial. Do you follow? Fourth factorial. So ibang language na tayo. We are now in a different language, no? We are from C# now in Python. Okay. We are from the analytical engine. Okay. Now we're in the IAS. Okay, let me just erase this first. I have a micro instruction here. No? This is the program. The program is actually in this, in this column. This is the address. Okay. And I have a micro instruction here which specifies data flow. When we say load M1, we say the accumulator receives M1. Okay, the receive is pointed by the arrow. Store M4, we say M of 4 receives the accumulator. Sub M2 means the accumulator receives its current value minus M of 2. Okay. Store M1 means M of 1 receives the accumulator. Okay. We'll just go through that anyway. No? Now, if you ask why is the first command in the first address comes at 0. Okay. Okay, it starts at 0. We jump 5. We jump to 5, but we don't just say 5, which area in 5. We say jump to the left. 0 to 19 means jump to the left. 20 to 39 means jump to the right. Because actually, a word is 40 bits and an instruction is only 20 bits. So 5R physically should be here. But it's not healthy to do that in a program, no? We usually write in a program sequentially. But so 5L and 5R are side by side. Do you follow? Okay. Can we trace this now? Okay. Okay. This is our first multiplier in M4, M1. No. Our decrement M2 and our partial product in M3. Okay. No, M4 pala ang ating partial product. No? Do you follow? So, the first thing to do is we load M1. We only have one accumulator lang. Okay? We only have one register, not 3. Okay? Load M1. This means AC receives M1. What will be the value of AC? Anyone? Can you chat me? AC na tayo ngayon. What's the value of AC? Labor, you came late. Labor, are you there?
Yes, sir.
What's the value of AC here?
4, sir.
4. Very good. It's easy, no? Okay. Kasi AC receives M1. Kumbaga parang ano, this is easier because we only have 1. This is 4, so AC receives M1. And then we say store M4. Okay. Sinong tatanungin natin? Any volunteer or else I'll call? Labor. Tapos na si Labor, no? How about Ursal? Mark, are you there?
1, sir.
1. Anong 1? Store M4. So what will happen? Ito ililipat sa M4, di ba? What do we mean by store M4? Whatever the value of the accumulator is transferred to M4. Okay? Am I clear?
Yes po.
Okay. Now we have sub M2. Okay. Harriet.
Yes, sir.
Okay. Sub M2 means AC receives AC minus M2. What will happen to AC? Its previous value. What is its previous value?
4 minus 1, sir, 3. Yan, yan.
3. Okay. Okay. Do you follow? So, medyo shortcut siya, no? Okay. Store M1. Vincent, Larisma.
3 po, sir.
Store M1. Saan malalagay yung 3? M of 1. Larisma?
Yes po, sir.
Which means our next multiplier is 3. Okay? Okay. Now we have mul M4. Okay. What does this mean? Ibale? Filin? Are you there, Ibale? Okay. Zwingli? Are you there?
Okay.
Yes. When we say mul M4, we are going to multiply the accumulator with what value? What's the value to be
3, sir.
multiplied? Huh? Come again?
3, sir.
No, the accumulator is now 3, di ba?
Ayun, sir.
We will multiply it with what value?
4.
4. So this becomes what? 12. Do you follow? And we
Yes,
store
sir.
this to M4, this becomes 12. Okay? Is that clear, Zwingli?
Yes, sir.
Okay, thank you, no? Ganap na naman tayo ng iba. Modin. Crystal.
Yes, sir.
Yes.
Yes, sir.
Did you see my worksheet?
Yes, sir.
When you say load
Load
M1,
number, sir, number 3, sir,
number 3.
from M1.
Wala namang iba, di ba? There's nothing else. So
Yes,
M1
sir.
accumulator becomes 3. Okay? And then Eunice. Estimada.
Sir.
Yes. We say sub M2, which means the accumulator will be subtracted with what value?
1, sir.
1. So what will be the answer here?
2.
2, no? And then we store M1. So this, which means we are going to store it here. It will be our next multiplier. Okay? Anyway, let me continue na lang, no? Okay? So, load M4. So this becomes 12. Mul M1. What is M1? It's now 2. So this becomes 24. Okay? And store M4. So this becomes 24. Okay? Load M1. So this becomes 2. Okay? Sub M2. So this becomes 1 because it's 2 minus 1. And store M1. So this becomes 1. Our last multiplier. Okay? Okay? And the accumulator is now 1. We load M4, which is 24. We multiply with M1, that's 24. And store M4, which will be our final answer. Okay? And jump 14 to the left. This is 14L. Jump 14 to the left is the whole, which means jump to itself. So you see, no, it's a little strange, but it's similar to the analytical engine. You can still see observe the evolution. Okay. Wala pa tayong bagong assignment ngayon, no? Kasi meron pa tayong assignment next meeting. Okay, any questions? Okay, now there's the second example. You can download it from there, no? Jump 60 to 19 ang una. This converts Fahrenheit to Celsius. Okay, later you will convert this again to find out if the temperature is above fever or not. So 132 to 1. So M1 here is 132. Okay. 32 in M2. Okay. Stored program concept ito, no? So everything, memory and programs are in the same memory, no? Do you follow? Data and programs are combined. 5, M of 3 is 5 here, N of 4 is 9 here. Okay. Load M1. What happens to M1? Million Daga. What happens to M1 here? Million Daga.
It is stored in AC, sir.
Yes. What is the value of AC now?
132, sir.
32, okay. And then we have sub M2. Okay, sub M2. Abiliera, Adrian.
Sir,
Sub M2,
32,
what
sir.
happens? Huh?
32.
So what happens to AC? 100 minus 32. Abiliera? I think it's lost, no? 100 minus 32 is 100. You follow? Mul M3. So 5. Okay. So 100 times 5 becomes 500. Okay. Div M4. So this is equals that divided by 9. 55.66. And store M5 we store, but sorry here. 6. Okay, and we do a hold. Do you follow? Everyone?
Yes, sir.
Okay. So any questions? Pero bang bagong dating? I'll check the attendance anyway again. Meters to feet. So ganon din, no? So here, our input is in, balik ka dito. Dito yung 4. Dito yung 3.28. Okay. So we load M1. AC becomes 4. We mul M2. So 4 times 3.28, this becomes 13.12. And we store to M3, this is 3.12, and then we hold. Okay. Of course, there are prints, there are output commands, no, but we will not do it anymore here. We assume that the final result is in the accumulator. Okay, you can download the worksheet from our regular site. So that's the IAS, the evolution. I will tell you the story next meeting. Okay, the evolution from the analytical engine. Okay. So if you get a documentation on EDVAC, don't be surprised if it looks like the IAS, no? Because they have the same author. Diagram. Walang nakasulat, no? Gusto ko hanapin, no, to compare it, but they're very similar, okay? EDVAC and the IAS. But the IAS was released slightly ahead, no? Just a few months before EDVAC. Talagang hinabol ni Van Neumann, no? Yung release to make sure that it's accredited as the first binary computer. However, no, the first binary computer was accredited to ABC. No? Van Neumann was accredited for the stored program concept. Okay. Any questions so far? Okay. I will not give you an assignment now. Next meeting, I will introduce the fourth factorial. And then sum and average. Okay. Programming assignment. You don't have a programming assignment. I'll give you a programming assignment no, on the IAS. Ito nun, nandito pala, no? Can we just, hide this first, no? I'll show this to you next meeting, okay? Pareho lang ito actually, no? Sum of the first four numbers, this time in the IAS, Celsius to Fahrenheit. Okay. And then compute the average of the first three numbers with loop. No, wala na yung without loop. Do you follow? No deadline yet. Wala pang deadline, no? It's hidden anyway, no? But I will give this to you next meeting after we have discussed the last assignment on the IAS. Okay. Then we will also look at the factorial program later on the PDP, no? Meron din tayong PDP, oh. IBM, I hope we can have IBM. Any questions so far? No questions. So I will not discuss any further lessons, no? Okay, I will give the assignment as I've said next meeting. Did I miss anyone? One ba tayo?
Yes, sir.
Yes. Ancheta, Tian, De Los Santos, Domingo, Dominguito, Hitgano, maraming absent. Modiquillo, Mulato, Rimulyo, Tayong, maraming absent. No? This morning I had a full attendance. Any questions? So bye for now, no? Thanks for coming, everyone.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you po, sir.
Thank you, sir.
Bye-bye, sir.
Bye.
Bye, sir.